Hello students, so today we will be starting a new chapter, chapter number 5, coal and petroleum. The various materials that you see around you can be grouped into two categories. One, natural materials and other man-made materials. Natural materials are those materials that we directly get from nature and we don't process it. For example, air, water, stone, granite, marble, gold, sodium chloride, coal, petroleum, cotton, etc. So these materials we get from atmosphere, earth's crust, rocks, plants and animals. Then other group is called man-made materials. We take some natural material, mix them or chemically react them, do certain changes and then we use them. For example, synthetic fibers, ceramic, plastic, petrol, diesel, alloys. We get metals from earth, but we mix the metals in some proportion to get an alloy which would have properties that we desire. Then metals mainly exist in the oxide form. So we convert the metal oxides to metals. So metals are also man-made materials. Is it okay? Now these natural resources are classified again into two categories: inexhaustible natural resources and exhaustible natural resources. As the word suggests, inexhaustible natural resources are sunlight, air, water, which will never get exhaust in your lifespan and for many generations. Exhaustible natural resources will not last for many centuries or for a long period. They may get exhausted, like potable water, which is available in well or in ponds or in lakes. In case you use them at a faster rate, they may get over or exhausted, but they will get replenished. Monsoon will come and water level will again rise. So such things are called replenishable exhaustible natural resources. Then we have got other category of exhaustible natural resources which are non-replenishable. For example, coal, petroleum, natural gas, various minerals, these things, once they get exhausted, it is not possible to replenish them. So we have to be very careful in this category of materials so that they will last for many years, and we should try to find alternatives of them. We will discuss this in detail later on. Now, as I told you that natural resources are of two categories: exhaustible and non-replenishable, exhaustible and replenishable. Let us discuss now fossil fuels which are in the category of exhaustible and non-replaceable, non-renewable. So first is coal. Coal, as you know, is a black solid. If we burn it, it gives energy. So we call it a fuel. Any material which gives energy is called a fuel. Now, coal, petroleum and natural gas, why they are called fossil fuel? Because we will be studying now that they are made from dead animals and plants. So we call it dead vegetative matter. Now, coal has taken around 300 million years to get formed. So at that point of time, we had dense forests in most of the places, and some places were having wetland, means low-lying areas where water used to get accumulated. So the plants which were in those areas, they due to natural phenomena, wind, monsoon and all those things, they used to die. They used to fall and die. And so once they have fallen, then on top of it other plant will fall after few days or after few months. So piles of dead plants got collected, and so these plants and even some animals may die. So these plants and animals, due to microorganisms, got decomposed. But this is a very slow process. Gradually, as the pile increased, the pressure increased, and as they went down and down, like so, we say the temperature also will increase. Like initially, suppose this is the earth's surface. This is the earth's surface. The plants now have come here. All these are plants. Dead plants at the bottom. So the plants which are at the very bottom, they are under high pressure due to the load of the plants above it, and as now they are near to the center of the earth, so temperature is also more. So the deep buried plants, deep buried vegetative matter is under high pressure, under high temperature, and there are certain microorganisms also, but as they go very deep, then then there will be no air, there will be no air, no water, so it will be less, but even then they will get decomposed. So it has taken around 300 million years for this vegetative matter to get converted to coal. First, what happens when it gets buried under high pressure and temperature, and microorganisms, they get converted into peat, dead organic matter. So first we will get peat. First peat will get formed, means dead organic matter will get formed. Okay. So first this peat will get formed, dead organic matter. Peat is nothing but dead organic matter. So first dead organic matter will get formed. Then with time it will get converted to brown color, which is called lignite. It is having around 60% carbon, because now due to temperature, whatever water is there and some other substances which can evaporate gets evaporated. Then you get bituminous coal, which is black in color. It is having around 70% carbon, and then anthracite coal gets formed, which is around more than 90% carbon. So this process of gradual transformation from dead vegetative matter to coal is called coalification. Is called coalification. Is it okay? So therefore we call coal as a fossil fuel. Fossil means made from dead vegetative matter. Now there is another term called carbonization. Carbonization means that first of all, carbonization is a very fast process. In this process also organic matter will get converted to coal gas, coal tar and coke, but that we do in our processing plants by destructive distillation of coal. So when we do destructive, I will be explaining you destructive distillation of coal. So when we do destructive distillation of coal, then we get coke from coal. I will explain you this later on. Then fossil fuels. are, we say, produced by coalification of dead vegetable and animal matter, whereas carbonization is fast process of converting coal to coke and coal tar, and carbonization is an exothermic process. You see this diagram. This is the tube. Here I have taken coal. Here I am heating with a burner. This is just a representation of the chemical process. And this is a fitted with a rubber cock, so that air is not there. So that we are heating in without air a negligible quantity of air. And when this coal is heated to more than 200 degrees Celsius, then all water and volatile matter will get converted to gaseous state, to vapor state, and it will come here. It will come now in this tube. Now in this tube is having water. So when these bubbles of gas pass through water, they form two layers. In the top we get ammonical liquor, means ammonia will get dissolved in water. In bottom there will be a thicker liquid which is black in color, that is coal tar, and still some vapors will remain, and those vapors will come out, and that vapors are called coal gas. If we put a matchstick here, this coal gas will burn. Now you see, once I see that now no more smoke is coming, no more vapors are coming, here the material that will get formed is called coke. Coke is more than 98% carbon, and it is porous, as many materials have got removed from it. So here I will get coke. I would see some blackish deposits on the side of this tube. So these blackish deposits are called gas carbon. So here I have got two materials, coke and gas carbon, and here I have got two materials, ammonical liquor and coal tar. Coal tar is also having many uses, I will describe, and this coal gas is distributed to the village which is near to this processing plant, because coal gas is an highly inflammable gas. Is it okay? So 5 substances are getting formed, and here I have taken bituminous coal, and now I have got coke. Now coke is having 98% carbon, it is porous, it is tough, so it is, as it is pure, it is used for extraction of metals and also for making steel. Okay, and here we get gas carbon, ammonical liquor, coal tar, and here coal gas. Is it all right? So then we will proceed further. So I have explained you this destructive distillation of coal. When coal is heated in absence of air or very small amount of air or oxygen, then all volatile matter will get removed. So there will be cracks, means it will become porous. Larger molecules will become smaller molecules. Now, as such, this method we will be learning in 12th chemistry, in organic chemistry, that there is a pyrolysis process which is similar to this. So we are doing similar to this. So therefore this is called carbonization. And black rich residue left is coke. It is tough and 98% carbon. So it is as it is pure, it is used for extraction of metals and for making steel. Is it all right? Now let us coal tar. Coal tar is a mixture of many substances. So by fractional distillation we separate those substances. Then those substances are used as the starting material for making various compounds like naphthalene balls, which were keeping in the clothes when you are storing them, so that insects should not spoil the clothes. Then It is used for making perfumes. It is used for making explosives. It is used for making dyes, drugs, the ointments. For various other purposes, this coal tar is used. Coal gas juice I have told you, coke juice uses also, so I have understood. Is it all right? So this completes about coal. In the next session, I will explain to you how petroleum is refined so as to get the products that we are using in our day-to-day life. Thank you. Hello students. So today we will continue with our chapter 5, namely coal and petroleum. Last time I explained to you how coal is formed and what are the various products that we get with destructive distillation of coal and their uses. This time we will study about petroleum. So we will study in the same manner how petroleum has got formed and what are the products we get from petroleum and what are their uses. So let us first start with formation of petroleum. Petroleum is not petrol. The other word for petroleum is crude oil. The oil that we get in the natural form from earth. Its formation is similar to coal, but this has got formed mainly in seas, oceans. So there, whatever aquatic plants and aquatic animals were there, when they used to die, they will definitely go to bottom of the bed. So they got collected at the seabed, and with time they also got decomposed, and it has also taken millions of years for it to get decomposed. When they got decomposed, because here the plants and animals, they were very tender and small in nature, and it was in different under the water, so their decomposition product is liquid, which we call it petroleum, and gas above it. Gas means it is having low evaporation temperature, low boiling point, okay, less than the temperature that is existing at the bottom of the at the place where we are getting the petroleum. So I will just show you. So when this liquid got formed, it flowed and it got collected between the rocks. So always petroleum is between the rocks. Now some water will also come. So density of oil is less than density of water. So in the bottom there will be water. So here there will be water. On the top there will be petroleum or crude oil, and on the top of it would be gas. So they would be in this order. This is my earth crust. So this is my earth. Okay, this is the earth. Then so if I dig a well, I will get gas up to here. If I dig it quite deep, I will get petroleum. So this is how this gas is called natural gas, and this is the petroleum, which is called crude oil or petroleum. Now so we have to dig the well and pump it out. Is it all right? So this also has taken millions of years due to high temperature, high pressure. The organic matter got decayed. Okay, all organic matter, dead organic matter got decayed, and so here these things are there. So definitely there will be some, all around it would be impervious rocks would be there, and they are in between those. They are got trapped between the rocks. So this is how it has got formed. Now, in India, they are found in Bombay High, Assam, Gujarat, river basins of Godavari and Krishna, etc. Now, many substances that we will be getting from petroleum and this gas, they are called petrochemicals. They are called petrochemicals. These petrochemicals, they are used for making detergents, synthetic fibers, polyester, nylon, acrylic, polythene, and other man-made plastics, bitumen, which is used for repairing of roads, for making of roads. Then hydrogen gas that we get from natural gas is used for production of urea fertilizer. Now, this petroleum has got so many products that we will be learning now. So, it is also called black gold because it is giving us many useful products. As I told you, petroleum is a mixture of many liquids. So we have to separate them. Separating the constituents of various liquids from petroleum is called refining of petroleum. Refining means as such purifying, but here refining of petroleum means separating the various the constituents of the mixture. As such, petroleum is dark oily liquid. It is having very unpleasant odor. Now you know that petrol, diesel, lubricating oil, paraffin wax, etc., all these materials we are getting from petroleum. So now we have to separate them. How to separate them? These are miscible liquids. So to separate this, we are doing refining by method called fractional distillation. Now, what do you mean by fractional distillation? Whenever two liquids you are having, suppose you are having two liquids. You are having two liquids and they are miscible. They are mixed together. But boiling point of one is 80 degrees Celsius and boiling point of other is suppose 110 degrees Celsius. So if I heat this liquid, so first I will get vapors of liquid having 80 degrees Celsius, and if I condense it, so I will get liquid of 80 degrees C and liquid of 110 degrees C would remain in the flask. So this is a very simplistic way of fractional distillation, that because of difference in the boiling point, so that difference should be there in the boiling point, more than 20 or 25 degrees Celsius difference should be there. When we heat, then first low boiling point liquid will come out and then high boiling point liquid will come out. If there are many liquids, this process will go on. But what we do for fractional distillation, we heat everything and we are having vapors of all. So we take vapors of all, and by a pump we pump to a very big tower. This tower is called fractional distillation tower, and here in this tower you have got various layers, partitions are there, so that I can drain the liquid from here. I can drain the liquid from here. I can drain the liquid from here. So this is designed in such a manner that when I take this vapor, so first, so the vapor that will be coming out from this place would be at a maximum temperature. So at this temperature, I will get only that liquid whose boiling point is that high. So gradually as I go up, I will get liquids of low boiling point. Okay, so this is called fractional distillation tower. So in this manner we separate the various liquids: petrol, diesel, lubricating oil, paraffin, and all those things are separated by this fractional distillation. Is it all right? Now let us try to see about natural gas. Now, as I told you that if this is my crude oil, petroleum, not petrol, then the top of it I will be having natural gas. So if I put the well only up to here, I will get natural gas. So natural gas is very important fossil fuel, because natural gas is compressed so that it will occupy less volume for same mass of gas, so that its transportation would be easy. Means more gas you will be able to transport per unit time. So the CNG is used not only as a fuel in transport vehicles, but it is also used in various industries as a fuel. The advantage of CNG is that it is less polluting. It will only form carbon dioxide and water. It doesn't have any other sulfur, phosphorus or any other material which is present in coal. So we say it is a cleaner fuel. Now, this CNG consists of mainly methane. We will be learning about its formula in 10th standard. Methane is CH4. So it consists of mainly methane. In your homes you might be having, definitely you are having gas cylinders. They are called LPG. They are called LPG. LPG means liquefied petroleum gas. They contain butane. Methane and butane as such, they are in the same family of organic compounds that we will be learning later on. So at high pressure, this is in the liquid form. So it is occupying small space in the cylinder. It is in the cylinder, it is occupying small space. But now for it to get transformed to gas, we open the regulator. So when it passes through the regulator, its pressure reduces and gas changes into a gaseous state. And we switch on, and we using lighter burn this gas and get the energy. Now advantage of this gaseous fuels are that we can easily control them. Whenever we want to switch on or switch off, it can easily be done, as compared to if we are using coal or wood. In primitive time, wood was being used as a fuel, then coal had come, and now we are using this gaseous fuel. Is it all right? Now this natural gas also contains hydrogen, and this hydrogen is all used for manufacture of fertilizers like urea and all those things. Is it okay? It is used as a starting material. And natural gas is formed in India also, Tripura, Rajasthan, Maharashtra, and in Krishna Godavari deltas and various places. Now, let us try to discuss, which I had initiated in my chapter of coal, that these fossil fuels are very limited in stock. They are expected to last only for few hundred years. So we have found various alternatives. We means all countries of the world had a meetings, and emphasis was laid that we should find alternative techniques. So now for getting power we will be using solar power, wind power, vehicles using hydrogen. So if we from this electric power we will be using now our electric vehicles, so that the use of petrol, diesel or petroleum products will reduce. And also we are making our engines efficient, so that they will require less fuel, petrol or diesel. Now, besides this reduction in usage of these products, that will increase the longevity of their presence in earth. Air pollution will also reduce and global warming will also reduce, because these are caused by conventional burning of fossil fuels. Is it okay? In India we have made one PCRA, Petroleum Conservation Research Association. They had given certain suggestions that how we can save petrol and diesel while driving the vehicles. Some of the tips are that you should drive at the speed at which the manufacturer says that it will require minimum petrol. Switch off the engine at traffic lights or at places where you are waiting. Keep always tire pressure of proper magnitude. Ensure regular maintenance of vehicle. Do pooling of vehicles, etc. So in this manner we are trying to reduce the usage of fossil fuel, and gradually as alternative energy sources will get fully functional, their usage will reduce to a very large extent, so that it will not cause much problem to the future generations. Thank you.